Alright, Florida Railroad Museum Air Brake Manual, Circular Training 99D2, effective July 27, 2010, and copyright Florida Railroad Museum. Table of Contents, Section, Air Brake Test, Single Car Test, Initial Terminal Test, Running Brake Test, Road Test, Backup Hose Test, Locomotive Brake System, number 6, Locomotive Brake System, number 24RL, Locomotive Brake System, Freight passenger car, freight and passenger equipment cutting out brakes, the AB family of brakes, the AB brake system of passenger equipment, the UC universal brake system, the D22 brake system, the emergency brakes valves, train line signal, water raising system, troubleshooting and safety tips, illustration, and diagrams. When in doubt, take the safest route. Introduction to air brakes. In 1869, George Westinghouse developed a straight air brake system for the railroad of applications. In a straight air system, no air is presented in the train line or brake pipe until emitted from the engineer's brake stand, normally as a normal application used by tractor-trailer streetcar brake systems. The system worked nicely for short trains. As the motive power increased and trains' length in the system became impractical, and it would produce extreme slack action due to the brake applying at the head end of the train before the rear. Second drawback was that any of the brake in the train line rendered the brake system inoperative. The automatic brake valve in 1872, it added a triple valve on each car connected to the auxiliary reservoir. Train line was kept charged with air, and throughout the triple valve, the auxiliary reservoir was also charged. The engineer would reduce the brake pipe pressure. Each triple valve would cause the venting of the air at each car. This would produce a more uniform application of the air brakes. If the brake pipe pressure was reduced by 5 pounds, the triple valve would operate to allow 5 pounds of pressure from the auxiliary reservoir to flow into the brake cylinder line and apply the brakes. When equilibrium of the air pressure was obtained, the triple valve would revert to neutral position and flow air would stop. Triple valve would hold the brakes applied until the brake pipe was recharged. When the brake pipe was recharged, the triple valve would simultaneously allow the brake pipe pressure to refill auxiliary reservoir and prevent brake cylinder pressure to atmosphere through releasing the brakes. The point where the brake pipe pressure and auxiliary reservoir pressure are equal and the triple valve moves to the neutral position is called equalization. The key to modern air brake system. Naturally, any brake in the brake pipe would cause the triple valve to operate, and auxiliary air pressure would flow into the brake cylinder line, causing the maximum amount of the braking in emergency application. The system was the basis for the air brake development, and freight systems evolved into the K brake system in the 1900, AB brake system 1930, ABD family of brakes in 1950. The ABD family includes the ABD and ABW and today's ABDX, ABDXL. Passenger system went to L to P, the U to D22 to 26C, and a variation ABD family freight brake valves. Florida Railroad Museum currently has AB, ABD, ABW, ABD, XL, UC, D22 systems in use. The most modern of the system, ABD family in the 26C, uses diaphragms instead of sliding brass valves. It has been found that the diaphragms require less maintenance and cleaning, do not wear as rapidly, and less prone to failure, and results in less out of the time in the route, brake failures, undesired emergency application failure in freezing weather, excessive leakage. Today, modern fleets of the unit train coal cars, 89-foot and trailer flats, 3 5-pack and 5-pack well cars are equipped with the most modern system. In addition, certain other devices have been advised to ensure the prompt response of the brakes to the engineer's desire. Other modifications, upgrades have been made to minimize brake pressure leakage. Part of the device include auxiliary vent valves on long cars longer than 75 feet to help the relay of emergency signal preventing air for another location additional to the triple valve built in the device with a portion of their valve themselves accelerate them both services of the emergency application. Modern construction practices include use of welded pipe to prevent loss of the air to the air edge pipe joints. One of the least expensive methods of keeping the brake pipe leakage to a minimum, changing the end hose gasket each time the car is on repair track. The more modern brake system locomotives have a pressure maintaining feature, which we'll discuss later under locomotive systems. Using training, all AB valves and it took an emergency brake application initiated with the engineer control saying about 1 second to relay a signal on 1,000 feet. As you can see, while with a mile of the train, the rear end shall be traveling at full speed, while the head of the end of it has been emergency application for 5 seconds. This can result in excessive stresses mid-train that can cause derailments related to damage in equipment, plants, and personnel. The ABD can relay emergency signals 1,000 feet in about 3/4 of a second. The ABDX, ABDXL can relay signal at the same 1,000 feet in about half a second. The electrical signal is finally approved that the emergency signal will be simultaneously throughout the length of the train. Stopping distance can be cut in better than half. Note the effects of a 15-mile-an-hour 5 or 6 car operation. Even with the outmoded brake equipment, our trains will stop at a minimum distance. It used to be that the car was given a clean oil test stencil, or CTOS, check every 3 years. The ABD system became more common in 1960 with the clean oil test stencil date extended 10 years. The 1990 dropped it altogether. Today, a car must have a single car test. The test portion clean oil test stencil once every 6 years, or when certain wheel conditions indicate possible brake failure and malfunction. Today, if the car passes the single car test, the brake valves do not have the full clean oil test stencil treatment. Philosophy of freight brake equipment is if it ain't broke, don't fix it. Air brake test. There are various tests that you need to be acquainted with. The single car test, the initial terminal test, the road intermediate terminal test, and running brake test and a backup hose test. Alright, the single car test is performed shop personnel to ensure brake system on a car operating as required. For all intent purposes of the test is only required when car demonstrates the air brake system is not functioning correctly. If the system is not functioning at all, the car must be repaired and taken out of service. Initial terminal test. This test is completed prior to leaving the initial train make-up terminal. Normally this would be Willow. After the train has been fully charged at 90 psi, so that the gauge at the rear end reads 15 pounds of feed valve setting on the locomotive, the brake pipe pressure should be reduced 15 pounds. Brake valve will be left in the lap or pressure maintaining feature cutout if so equipped. The brake pipe pressure gauge shall be noted for 1 minute to determine the brake pipe pressure leakage, which may not exceed 5 pounds. If the pressure has not fallen more than 5 pounds at the end of 1 minute, the further reduce the brake pipe pressure to a total of 20 pounds. Notify the conductor the brakes are set. The conductor or trainman shall walk the train to ensure that each car brake has applied. When the conductor of the trainman reaches the rear end, they shall signal the engine man to release the brake application. Once the brake are released, they will walk the train again to ensure each brake has released. No hand brakes are set. After the completion of the test, shall have notified that the engine man. At the completion, shall notify the engine man of the number of cars on the train and the number of operative brakes. Our running brake test. After departure initial terminal, as soon as practical, the engineer shall make a light service application of automatic air brakes to determine that the brake system is operational. If not required, it is not required that the conductor respond to this application, as the engine man can tell the brake has applied when the train slows. Alright, a road test. The test is conducted en route when adding or removing cars that have been tested in the intermediate point. Once all the switching is complete and the train is charged, the conductor trainman shall ensure the brake on the rear car applies and release. The engine man makes the application and release. Alright, your backup hose test. When the train is to be shoved and backup hose and the conductor. When the train is to be shoved and a backup hose or a conductor backup position is to be utilized, the backup device must be tested following the initial terminal test. The device should be open and the brakes must apply. This is not to be an emergency application, merely service testing to ensure the device is working. The whistle must also be tested to ensure it functions as intended. Locomotive brake systems. The Florida Railroad Museum has 3 types of locomotive brake systems in use: the number 6, the number 24, and the number 26. Number 6, number 24L, and 26. The following have is how the museum's equipment is set. The FGC 100, number 26. The Seaboard Airline, number 6. The Florida Gulf Coast Railroad, 822, number 6. Florida Gulf Coast Railroad, 835, number 6. Pennsylvania Railroad, 8604, 24RL. Some components of air brake system components also to allow the museum locomotives. Some of the examples of these following: 2 duplex air gauges mounted on an engine and control stand. They are combined with a main reservoir, equalizing reservoir gauge, combined brake pipe pressure, brake cylinder pressure gauge. Duplex gauges are common to all locomotive systems and all that are required of locomotive operation. There are other gauges that various deadman control systems which do not use the gauge indicate with the control air pressure to operate various electromagnetic systems such as reverser. Flow meter would show the cubic foot and a minute flow rate feeding the brake pipe. Standard pressures on all locomotives are 130 to 140 pound main reservoir, 90 pound brake pipe, and equalizing pressure 80 to 90 pounds control air pressure. The air compressor takes filtered air from the atmosphere and compresses it and stored in a high-pressure main reserve. The air is heated as a result of compression, so after the coolers cool the heated air before it enters the system, so that prevents excessive moisture being carried through the system. The main reservoirs are protected with the overcharging safety valve set at 150 pounds. The brake valve cutout valve opens and closes communication between the brake valve and the brake pipe. It must only be opened on the controlling locomotive. All other locomotives that consist under power that have the valve closed must have the valve closed. Failure to close the valve will result in the trailing locomotive to continue charging the brake pipe when controlling locomotive is reduced with the air pressure to apply the brakes. All locomotives use straight air to apply the locomotive brakes. The brake cylinders are protected by a cutout cock on each end of each truck, on each side of each truck, to cut out the cylinder in event of the brake pipe fracture, ruptured hose, or other malfunction. This will allow the locomotive to complete its work even though the portion of the brake system is disabled. Alright, the number 6 locomotive brake system. 6 brakes include the following components: air compressor with governor, main reservoir, safety valve, aftercooler, automatic drain valve with cutout cock, feed valve, equalizing reservoir, independent brake valve, reducing valve, distribution valve, and safety valve, transfer relay air valve, multiple operation, air gauges, standard bell ringer, combined strainer check valve, emergency brake valves, air collectors, filters, brake cylinders, piping cocks, and hoses. The automatic brake handle positions are from left to right: release, running, holding, lap, service, and emergency. Release, running, holding, lap, service, and emergency. Release, running, holding, lap, service, and emergency. And the number 6. The valve position of the SL type of the independent brake release and application. Train brake is applied by moving the automatic brake valve handle in the service position, then to lap. Consider the skills required to get just the right amount of application. Independent brake has a bail feature. By depressing the independent handle, locomotive brakes are released and bailed off during the automatic brake application to prevent sliding of the locomotive wheels. The engine can also power apply with keeping the train stretched and preventing an undesirable slack action. Note, once you have the released surface application, you need to make another surface application. You will have to make a greater reduction than the original. The system may not have fully recharged. However, you will still have a full emergency braking. The emergency application is made moving the automatic brake valve to the emergency position, leaving it until the train stops. During an emergency application, the locomotive brake should be bailed off to prevent sliding from the locomotive wheels. With either a surface or emergency application, move the handle of the running position to restore the brake pipe pressure. Whenever the release position in the main style of number 6 brakes, relief of the position block preventing the handle to be placed in the tent. Relief of the position supplies air for the main reservoir to the brake pipe, rapidly recharge the system. The function used is typically found on mountain grades to restore the depleted brake pressure should the engineer squander his air on a descending grade. The use of the release position potentially overcharges the brake pipe, bringing it up to main reservoir pressure and results in sticky brakes. The number 26 locomotive brake system. Number 26 is the most modern brake system we use. Simplicity's sake must be the terminology of the number 6 system applies to all other locomotive brake systems. Alright, the number 26 system includes the following components: air compressor, governor, main reservoir, safety valve, aftercooler, air automatic drain valve, 26C automatic drain brake valve, multiple unit 2A selector valve, cutout cock feed valve, equalizing reservoir, SA26 independent brake valve, A1 reduction selector valve, 26F control valve, J1 relay valve, J relay air valve, vent valve, air gauges, sand bell ringer valves, air brake valve, emergency brake valve, dirt collectors, filters, brake cylinder piping, cocking hoses. The automatic brake handle position for the left, the right, release minimum reduction, service suppression handle off. Emergency. So release minimum reduction service suppression handle off of emergency for the number 26 brake system. The minimum reduction position is also called the first service. Should be noted when the handle is moved with the minimum reduction position into the service range, the valve is self-lapping. The SA26 independent brake valve position release and application independent is also a self-lapping brake. The automatic valve handle is removed with the handle off position, while the independent valve handle is removed with the release position. The multiple unit 2A valve in the 3 position, lead, dead, trailing 6 or trail 24, 26 with 8. We do not run engines and multiple units, so the valve is always left in lead or dead position. To release emergency application, the automatic brake valve must be placed in emergency remain for the 1 minute before moving the release. You can nullify the safety control application and pressing the foot valve, making a minimum application 25-pound brake valve cylinder pressure with the automatic independent brake valve or independent brake valve. After safe control application, the brake valve handle must be in suppression remain 3 until PC light turns off. Alright, the 24RL locomotive brake system. The system is far more complex, expensive to maintain obsolete brake systems we have. It utilizes relay valves were developed and used almost at 100 years ago. The cost of maintaining system is prohibitive. Often parts are no longer available. The number 24RL system includes following: air compressor for the governor's main reservoir, aftercooler, safety valves, automatic drain valve, automatic brake valve with cutout cock, first service cock, S40F independent brake valve, rotor air valve, feed reducing valves, B3, F1, F6, F8, F1, 864 relay valve, safety valve, combined equalizing reduction limiting reservoir, control valve, combined auxiliary, emergency displacement reservoir, air gauges, emergency brake valve, brake cylinder piping, cocking, and hoses. The automatic brake handling position left to right for the number 26 or number 24RL will be released running first service lap, service and emergency. Independent brake valve positions are running release in application, and the small clock on side of the brake stand is marked in and out. The cock pressure maintaining feature of the K3A rotor air valve has 4 position: freight lap, passenger lap. Reoperate the unit in freight. The valve used in multiple unit operators, cut in and cut out, application release function, independent brake valve control, the emergency feature, split reduction feature. Alright, freight and passenger equipment. All freight and passenger equipment is the brake pipe of the train line runs the length of the car, terminated at each end of the angle cock, end of the air hose. The angle cock is the line with the pipe. It opens and air will pass through it. The opposite of the angle cock is the cutout cock. Air will pass through the cutout cock when positioned perpendicular to the pipe. Both styles of valves have a port mark or groove raised line indicating the position of the airway, and then vent handling missing of the port mark will indicate the valve is open or closed. So over the operation portions of the both freight and passenger equipment is branch pipe, cutout cock coming off the train line. Cutout cock is perpendicular with the pipe when opening. The brake is cut in the parallel to when the closed brake is cut out. Care must be taken to utilize brake pipe cutout cocks on locomotives. There are some of the parallel pipe when opening, and some are perpendicular with the pipe when opening. Head over the port marks on the valve. Downstream branch pipe cutout cock is connected with the brake pipe to that hole of the actuating valve of the brake system. From the bracket piping extends to anywhere from 1 to 3 to 4 tanks. Various systems verifies various quantity of the brake cylinder, possible relay valves. other auxiliary devices of the brake cylinder vent line, if so equipped with a retaining valve. Alright, on long freight cars there may be quick service valve, emergency vent valve on the A end, quick service valve and the emergency vent valve on the A end. On the B end of all equipment location of the handbrake. On some passenger cars, there may be a quick service valve on a separate pipe brake and emergency vent valve, one or two conductor valves, a feed air valve for when water raising system on cars with the disc brake, where they are bud indicators on both sides of the car of each truck. The brakes are applied and a red plunger will display. When released, plunger will pop back into the housing, indicates the disc brake has been released. Each car is equipped with a handbrake on the B end. All handbrakes must be in good operating condition. Brake shoes, either cast iron composition, must have at least 3/8 inch remaining or replaced. Brake pads on the disc brakes must be replaced. They are down to a 1/4 inch. Brake pistons travel to vary with the car. Different types of system use the disc brakes. Non-standard piston travel. Travel is restricted by design event, even with all pads worn condemning. Limiting piston travel will be set within the limits. Most standard AB freight systems have an anomaly of 7 to 9 inches. In anything more than 9 inches of travel, considered a non-effective brake. A tool car has a different brake cylinder placard designation. Piston travel of 5 inches. The UC type equipment includes multiple unit car. Kentucky Club Southern baggage car has nominal position travel 3 inches. Truck-mounted cylinders have 5-inch travel. Most modern equipment, included US, UC, and D22 systems, are equipped with automatic slack adjusters. To compensate the brake shoe wear and all other modern freight equipment is equipped. Some historic railroad cars, such as some combustion 3-wagon top box cars, do not have this feature, and piston travel must be manually adjusted. Maximum locomotive piston travel is specified on the blue card in each locomotive cab. All 8 to 9 minutes to charge the train of the AB and UC equipped cars, plus another 10 seconds for each car and consist. If the car consists of the cars are equipped with D22 modified AB brake system, charging can take as long as 30 minutes to fully charge. On cars equipped with a water raising system, low water levels increase the amount of the air required to charge the water tank. Also increases the length of the time to fully charge the car. If you have the car still charging, the consistor will be cleared during an internal leak test as well. The locomotive airflow gauge is so equipped. Cutout brakes. The cutout brake of the AB equipment enclosed with the branch pipe, cutout cock, drain, combined emergency auxiliary reservoir, pulling release valve with the bleeder valve connected with the bottom of the AB service portion. On cars with a relief valve, such as a short line leaf line, also drain the main reservoir by opening the drain cocks on the bottom of the tanks. This will prevent air from leaking back into the cylinders and cause the brakes to apply, resulting wheel slide. Alright, on the UC type brake system, the clove of the branch cutout cock and bleed the auxiliary surface of the emergency reservoirs. And D22 passenger system, clove of the branch pipe cutout and bleed off of the combined reservoir, pulling the release valve in the surface portion, bleed the main reservoir and opening the drain cocks on the bottom of the tanks. In the event of the broken brake pipe, an affected car must be moved to the rear of the consist. After placing the car on the rear, connect air hose closed with the brake pipe angle cock on the damaged car only. Open the angle cock on the working car, which will charge the air hose between the equipment. If break-in 2 occurs at this point, the head end of the train will still go in emergency. Ensure the handbrake of the damaged car is operable. Station trainman on the car to apply handbrakes in the event of breaking in 2. Alright, the AB family brakes. The AB family includes original AB brake system as well as the ABD, ABW, ABDX variants. Any values will go to the AB pipe brake with only changing length of the studs required. Each of these valves are improvement in the previous generation. Alright, looking at the control valves on the side of the car, the pipe bracket is in the center of the right of the surface position. Control of the surface brake application release to the left of the emergency position, which control of the emergency position application and release includes inside of these portion devices will cause the brakes to apply faster. Use auxiliary reservoir to help replenish the brake pipe during release of fast release times. After feature keeps running a valve open for 70 seconds after emergency application. Sure, the train will come to a complete spot. Prevents the engineer from releasing the emergency application. Will still move the combined auxiliary emergency reservoir that is fed with the pipe bracket portion. Also packed over the pipe bracket and brake cylinder line. Small lathe line that runs retaining valve. The retaining valve is a device that when the handle valve handle is turned up will remain in portion of brake application on the car after brakes are released. That is most commonly used in the mountain territory before descending steep upgrades. The first notch up is called high pressure and will retain brake application required 3 minutes. The second notch is called slow direct exhaust will remain low percentage of the brake application. The down position direct exhaust and is the only position we use in setting with the brakes will release immediately, no retaining pressure. The brake is put and release. The brake pipe is recharging control valve, vents, brake cylinder pressure, retaining valve, atmosphere. Are the AB brake system passenger equipment. The AB system even the passenger is almost identical to the D22, so the only differences are the system even the freight combined reservoir instead of the D22 3-part reservoir and a main reservoir charging, checking valve located with the face of the pipe bracket. The AB system is the same as the freight except for the brake cylinder line back off of the pipe bracket now goes on to the 800 cubic inch dummy tank relay valve. The dummy tank fools the AB system into thinking it is filled with the 800 cubic inch freight brake cylinder. This sets up the proper pressure for the relay valve to take air over the main reservoir and send it to the brake cylinder lines. Operation identical to the D22 system. There's now a 2 quick service valve separate with the ABD system feature incorporated, cutting out the brake is identical to the operation of the D22 system. Or the UC brake system. The UC brake or universal brake system valve in World War I was adopted many even included for the multiple unit electric operation on 1 or 2 more multiple unit cars with the DNLW came the additional filler pieces that allow the operating electro-pneumatically. Looking at the control valves mounted with the pipe bracket portion on the right of the equalizing reservoir, left with the quick action portion of the high pressure cap piping with the piping bracket goes to the brake pipe cutout cock, the brake cylinder exhaust, retaining valve, the auxiliary reservoir, surface the reservoir, the emergency reservoir of the brake cylinder operating with a similar A-brake system, all system operating in harmony. Remember, the UC brakes are all 3 reservoirs must be drained by opening the drain cocks on the bottom of the tanks. There's no bleed lever for the like AB or D22 systems. Most often, UC brakes have 2 brake cylinders, 1 for each truck. Simplified brake rigging required to change mechanical force that apply the brakes. The D22 brake system was developed in World War II, still in use through its life, but may be short-lived. The system was designed to improve service stability, serve the release with the graduated release of the emergency transmission speed, release after emergency, big boost. 22 system was increased capacity. The UC valve was designed 2 16-inch brake cylinders. D22 was designed pulling device to operate 1 or more large capacity relay valves allowed with the system function on any side with the numbered arrangement of the cylinders. Looking at the pipe bracket on the right, it's for the portion on the left of the emergency portion. The portion is the larger of the AB brethren with the share of the same function, mainly of the same parts. From pipe bracket of the pipe that go to the branch, pipe out, cut out, go to the combined service reservoir, combined reservoir, displacement volume, auxiliary, and emergency reservoir. Relay valve, pipe bracket, and the brake cylinder exhaust, retaining valve of the supply main reservoir. Some else come off with the brake pipe as an A2 quick service valve with a separate brake pipe bracket. In systems, brake cylinder pressure does not come from the auxiliary reservoir pressure. Instead, the auxiliary reservoir pressure goes from the relay valve that acts for the thermostat, allowed with a large quantity of the air to maintain reservoir to go in the brake cylinder. By the same token, the system goes with the relay valve allowed for the main reservoir to recharge vents of the brake cylinder pressure to retaining valve. Common to all passenger system, the UC, D22, and AB with relay valve are additional cutout cocks located in the trucks and cylinders. Each large 16-inch cylinder on the UC system has side vent cutout cock feeding it. The other system has a side vent cutout cocks located near each of the truck that disable the brakes of the truck only with bleed any of the air in the downstream system. And this valve will cut out one truck, leaving the system working to provide the half braking power. With the other truck, the tree has off the tread braking system or the disc system. Again, 2 cutout D22 brakes over the branch pipe cutout with leave the air on the U of the bleed valve at the bottom, serve the portion drain main reservoir. Your emergency brake valves. On each passenger car, their emergency brake valve. Pulling the device will cover the emergency application of the brake system. Abruptly stop the train. Emergency stops at low speed will operate with knock people down to injure them. At low speeds, we can knock people down and injure them. We can certainly use the valve is just, when be certain the use of the valve is justified. There's a caboose brake in each of the cabooses. All the way to the left is the release position. Each notch of the right allows more air to be exhausted from the brake pipe and creep of the brake after the first notch of the train is emergency. The A2 caboose valves, once application is started, the valve will not return to release position until it has moved into the emergency position. This is a mechanical locking feature of the valve. Your train line signal. There is the 3/4 inch pipe extended to the length of the passenger car coupled with the end hose throughout the train length of the locomotive that's carried by 45 pounds of air pressure. Each car was equipped with a discharge valve pull that will reduce the pressure line, causing the communication whistle to blow in the locomotive cab. Parts of these systems no longer available. We have abandoned the lines, removing them when possible. Handheld radios serve the same purpose. Water raising system. Cars equipped with water tanks under the car utilize to reduce air pressure through the brake system. Pressure out of the water tank, pressure force water flow of the pipe into the various toilets and faucets, appliances used for the passenger and crew. Multiple unit cars have a custom-made pressure tap with a Missouri Pacific caboose that utilize with a top-bottom grade feed water tank, which does not require air pressure to operate. Water-filled ports, outer water raising equipped cars that have the valve next to the water with the input. Turning the valves will stop the flow of air pressure into the tank, simultaneously bleeding off existing air pressure in the tank. Low water levels in the tank means there will be more air to bleed off due to the caution on bleed valve slowly to relieve the pressure before inserting its hatching water-filled hose. Once the tank is full, in return, bleed valve to ensure the position of the tank will be recharged. Air blowing around the water-filled ports is a source of brake pipe leakage and should be repaired and written up for repair. Alright, troubleshooting and safety tips. Keep tabs on the cars with cutout brakes to ensure the brake branch pipe cutout cock is not leaking. Charging the reservoir would cause the stuck brakes. If developing sticky brakes, try the number application release to see if it solves the problem. Always hold the end of the air hose at the glad hand and brace it against your leg before opening the angle cock. Even the brake pipe has dumped, the leaking reservoir could partially charge the brake pipe. Loose flying air hose can seriously injure. The smell of stuck brakes is very distinctive. Steel on composition. Respond to strange smell. Stopping inspection train for the stuck brakes. Alright, then you show the illustrations. Figure 1 is your AB control valve emergency portion service position. Figure 2 is the ABD control valve service portion emergency portion. Figure 3, the AA valve and the AA and AV and the ABW control valve service position. Figure 4, you have your U12BD universal control valve, which has a high pressure cap, strainer filling piece, quick action portion, pipe bracket, equalizing portion. Figure 5 shows the D22 brake control valve, safety valve emergency portion, pipe bracket, double check valve service portion, duplex release valve, graduated release valve, release interlock valve, quick service limiting valve. Alright, this shows exterior, show the control valve pipe bracket. The section view showing the dirt collector pipe. Figure 6 is combined dirt collector cutout cock reinforced flange unit fitting. Figure 7, the Westinghouse position 3-point position retaining valve. Figure 8, combined auxiliary emergency displacement reservoir. Alright, I turned this the wrong way actually. Let's go back. Alright, air brake manual. The FB3 retaining valve, 1/4 inch angle cock air brake standard hosing, 10 inch pipe nipple, 10 inches long, 1/4 inch straight coupling. 1/4 inch brake to the branch pipe T, which goes to the half-quarter inch angle cock ARR standard air brake hose with gland hand. The branch pipe goes to the combined dirt collector branch pipe cutout, which has emergency reservoir pipe 3/4 inch, 3/4 inch auxiliary reservoir pipe, and they go to the combined auxiliary emergency reservoir, and then the 3/4 inch retaining valve pipe goes to the retaining valve. And also from the combined dirt collector and pipe out, or your ABW, ABDX, UC22 goes to the ABD brake cylinder. Alright, pipe connection for the pipe bracket of the U12 BD Universal, 3/4 inch auxiliary reservoir, pipe emergency reservoir, pipe exhaust, cylinder exhaust, branch pipe bracket pipe, service brake pipe, emergency brake pipe cylinder, emergency reservoir, service reservoir. Show the emergency reservoir, service reservoir, the 5PF dummy coupling, 1/4 inch by 1/4 inch angle cock, 1/38 inch close, the 1/4 inch by 1/4 inch by 1 inch branch pipe T, 1 cutout cock. When 2 brake cylinders are used, the connection shown 1/34 inch brake to the B31A conduction valve. 3/4 inch, 1/4 inch angle, F dummy coupling, 1/4 inch FP coupling. When 2 brake cylinders are used, the connection shows show the central figure direct collector auxiliary reservoir drainer, U12 BD universal brake valve, 1.5 cutout cock, side vent slack adjuster, brake cylinder, and then it went from to the retaining valve, 1.5 inch pipe, 3/4 inch pipe. Alright, from the top you have the T type A water filling valve, heater connector, water tank, air storage tank, heater connection, outside diameter LP A1A combined governor, retaining valve, combined reservoir, D22 air control supply reservoir, drain cock, F6 relay valve, A2 quick service valve, E brake emergency, E brake B3B emergency brake valve. Your UHS brake cylinders and B16 D1 slack adjusters on the brake cylinder pipe, cutout cock locking handle, and armed hose with thread and male units. Your D22 air control valve, emergency brake valves, the E3 application brake valve, and then it goes into the male union, armored threaded male union, angle cock double locking handle, hosing, coupling on both sides, split down the middle. Alright, supply reservoir, cutout cock, 3 relay supply pipes, 3/4 inch supply relay charge valve, reserve charging check valve, ABDX control valve, combined auxiliary emergency reservoir, auxiliary reserve pipe, retaining valve, relay valve, 3/4 inch brake pipe, your glad hand angle cock, 1/4 inch brake pipe, straight coupling, AR standard air brake, ball angle cock, 800 cubic inch double tank ABU brake cylinder. This shows your air compressor hole, governor, HB8 or 6, safety valve main reservoir, safety valve retaining, safety valve motion pad after cooler. This is up front. Then you have your air brake cylinders down here. Your 6K KR distribution valve, angle cock, vent valve, emergency portion check valve, cutout cock, emergency valve, air, and the brake valve handling, your duplex air gauges. And that was your reading of Alright, that completes the reading of your Florida Railroad Museum Air Brake Manual.